Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on Laplace Transform for analysis of continuous time signals. Laplace transform represents continuous time signal in terms of complex exponential, that is e power minus st. Laplace transform can be used to analyze signals or functions which are not absolutely integrable. Continuous time signals can also be analyzed effectively using Laplace transform. Laplace transform of impulse response is called system function or transfer function. Laplace transform of x of t is equal to x of f integral x of s integral over minus infinite to plus infinite x of t into e power minus st into dt. Types of Laplace transform. It can be classified into two types. Bilateral is Laplace transform and unilateral Laplace transform. Bilateral Laplace transform are also called as double-sided Laplace transform. Unilateral Laplace transform are also called as one-sided Laplace transform. Unilateral Laplace transform can be defined as x of s is equal to integral over 0 to infinite x of t into e power minus st into dt. Bilateral Laplace transform can be defined as integral x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. Next, relations between Fourier transform and Laplace transform. Laplace transform of x of t is equal to x of s integral over minus infinite to plus infinite x of t into e power minus st into dt. Substitute s is equal to sigma plus j omega. Therefore, x of sigma plus j omega is equal to, instead of s, you can substitute sigma plus j omega integral over minus infinite to plus infinite x of t into e power minus sigma plus j omega into t. Now we can split both terms. Integral over minus infinite to plus infinite x of t into e power minus sigma t into e power minus j omega t into dt. Therefore, x of s is equal to Fourier transform of x of t into e power minus sigma t. Therefore, sigma is equal to 1. We can get x of s is equal to x of omega. Therefore, s is equal to j omega. This is the relationship between Fourier transform and Laplace transform. Convergence of Laplace transform. Laplace transform is basically a Fourier transform of x of t into e power minus sigma t. If the Fourier transform of x of t into e power minus sigma t exists, then Laplace transform of x of t also exists. Fourier transform of x of t into e power minus sigma t must be absolutely integrable. Integral over minus infinite to plus infinite x of t into e power minus sigma t into dt should be less than infinite. ROC of Laplace transform, the range of value of sigma for which the Z Laplace transform converges is called region of convergence. This is the time representation of signals. From time domain representation to frequency domain representation, the whole sine waveform can be represented by t in terms of 1 kHz. In frequency domain representation, 1 kHz. The full half cycle can be splitted by 2. It can be represented as t by 2, t by 2. Now in terms of frequency domain representation, in terms of 2 kHz. Next one, Laplace transform of x of t into e power at into u of t and plots its ROC. X of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. X of t means e power at into u of t. Now we can changing the limits from 0 to infinite. E power minus t we can take it as common, s minus a into dt. Now we can differentiate and then substitute the limits. We can get it as here 1 divided by s minus a. S should be greater than a. ROC with respect to omega and sigma, j omega and sigma, when a greater than means greater than a will be the ROC part. Laplace transform of x of t is equal to e power minus at into u of minus t. Now we can change limits from minus infinite to 0. We can get it as here 1 divided by s minus a. S should be less than a. The less than of the ROC part will be the ROC of e power minus at into u of minus t. Next one, partial fraction method. Laplace transform of e power at into u of t is equal to 1 divided by s minus a when s should be greater than a. Laplace of minus of e power at into u of t, which is equal to 1 divided by s minus a, s should be less than a. Laplace transform of e power minus at into u of t, which is equal to 1 divided by s plus a, s should be greater than minus a. Therefore, Laplace transform of minus e power minus at into u of t is equal to 1 divided by s plus a, then s should be less than minus a. Initial value theorem, therefore f of 0 is equal to s tends to infinite limit s into f of s. Next, this is the inverse Laplace transform results. E power minus a t into u of t Laplace transform power with 1 divided by s plus 1. Real of s should be greater than minus 1. Minus into e power minus 2t into u of t Laplace transform means we can get minus of 1 divided by s plus 2. Real of s should be greater than minus 2. E power minus t into u of t minus of e power minus 2t into u of t, we can get 1 divided by s plus 1 minus of 1 divided by s plus 2, when real of s should be greater than minus 1. E power minus t into u of t minus of e power minus 2t into u of t, we can get 1 divided by s plus 1 into s plus 2. Real of s should be greater than minus 1. Now we can see the applications. It is used in analysis of electrical and electronic circuits, breaking down the complex differential equations into simpler polynomial forms. Laplace transform gives information about steady as well as transient states. In machine learning, the Laplace transform is used for making predictions and making analysis in data mining. Laplace transform simplifies the calculation in system modeling. This is how it is used in signal processing or frequently opted for signal processing. It is used to study signals in the frequency domain. Small frequencies in the signal in the frequency domain that can expect the signal to be smooth in the time domain. Filtering of the signal is usually done in the frequency domain, for which Laplace acts as a tool for converting a signal from time domain to frequency domain. This is the time domain representation to frequency domain. For the linear differential equation, we are applied to your time domain representation. For the time domain representation, while we taking the Laplace transform of linear differential equation, we can get Laplace transformed equation, and then Laplace transformed equation, we can taking the algebra, we can get the Laplace solution. For that, we can applying the inverse Laplace transform, we can getting the time domain solution. This is the flow process of Laplace transformation. Find the inverse Laplace transform of x of s is equal to 4 divided by s plus 2 into s plus 4, a by b by, now we can substitute for s is equal to minus 4, we can get b is equal to minus 2, s is equal to minus 2, we can get a is equal to 2. Now we can substitute in your above equation 2 by s plus 2 minus 2 divided by s plus 4. Now we can apply the inverse Laplace transform, we can get the results as x of t is equal to 2 into e power minus 2t into u of t minus of 2 into e power minus 4t into u of t. Now we can see the assessment. Define Laplace transform. Laplace transform can be defined as x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. The relations between the Fourier transform and Laplace transform is given by x of s is equal to x of omega. Therefore, s is equal to j omega. List the types of Laplace transform. First type, unilateral Laplace transform. Second type, bilateral Laplace transform. Define ROC of Laplace transform. The range of value of sigma for which the Laplace transform converges is called as ROC of Laplace transform. Laplace transform of unit step function is given by x of s is equal to 1 by s. Define convergence of Laplace transform. Laplace transform is basically a Fourier transform of x of t into e power minus sigma of t that must be absolutely integrable. Bilateral Laplace transform is also called as double-sided Laplace transform. Thank you.